Hey, grade 12s. I had a question about question 2, or question 8, I should say, from lesson 2, page 188. So this is from the correspondence portion, or the end of our workbook pages in our blue work booklets. And in question 8, they ask us to find the concentration of the aluminum plus 3 ion. We have a saturated solution of aluminum hydroxide. It's always important to know that the solution is saturated, because that allows us to figure out an equilibrium expression, and this is a solubility equilibria. They tell us the value of the Ksp. So there's only one salt here. We're going to start with the same big 3 steps as always. We're going to start with the balanced equation for the dissolving of aluminum hydroxide. So aluminum hydroxide is going to break apart at equilibrium. Again, two-way arrows. This is an equilibrium situation for the aluminum ion and hydroxide ions. Aluminum hydroxide breaks apart to form aluminum and hydroxide. We know from experience and from our chart that hydroxide gets a charge of 1 minus, and aluminum in group 3 on the periodic table gets a charge of 3 plus. To make this balance, we can see that 3 hydroxides are here, so we have to put a 3 for hydroxides here. A balanced equation that balances in terms of the number of ions and also in terms of overall charge, plus 3, and 3 minus 1 is minus 3, makes total charge 0 here and 0 here. This is required to do all the future steps in our equilibrium expression. Now, my second step of my big 3 steps is a molar ratio. My molar ratio is, for every 1 aluminum hydroxide that dissolves, I get 1 aluminum ion and 3 hydroxide ions. So if X amount dissolves, I will get X amount of aluminum and 3X amount of hydroxide. Again, remember what the X's stand for. X on the reactant side of the arrows, on the left-hand side, talks about the molar solubility, the moles per liter that dissolves. X's on the product sides of the arrow refer to the concentration of each ion when the solution's at equilibrium. We don't know their values yet, so we have to put variables in its place. The third of my big 3 steps is my Ksp expression. Ksp is equal to concentration of my aluminum plus 3 ion times the concentration of my hydroxide minus 1 ion, and again this 3 as a coefficient becomes the power of 3 in my Ksp expression. Again, in this form, this is when I ask you for a Ksp expression, this is what gets you the marks, talking about what the ions are and the powers to which we're going to multiply them. Okay, now let's change this to math. Okay, substituting in place of aluminum, we know the value will be X. So I'm going to put an X. In place of hydroxide, the value will be 3X. And again, we have to remember to cube it. Now be very careful here. This is a place where I chronically make mistakes. I so often get excited and go, okay, 3 cubed is 9, and then I do the head smack, because 3 cubed means 3 times 3 times 3, which is 27. X cubed is X cubed times X is X to the 4th, so this is going to factor out to 27x to the 4th. So we have a value for Ksp as being 27x to the power of 4. So that's quite the big expression. Now let's take a look, like everything else, at this point that I have a simple math formula. Either I'm saying here's the Ksp, find X, or here's X, find the Ksp. In this question, they said, here's the Ksp. This is the value of Ksp. We know this number, so I'm going to put this number here in place of this variable. So we know that the number for Ksp is 3.7 times 10 to the minus 15, and that's going to be equal to 27x to the power of 4. Okay. Let's do a little bit of math here. I'm trying to isolate X by itself. So the first thing I'm going to do is divide both sides by 27. That allows 27s to cancel, and I have 3.7 times 10 to the minus 15 divided by 27 will give me X to the 4th. So let's try that in our calculator. We have 3.7 times 10 to the minus 15. So we go X minus 15. And I want to divide that amount by 27. At this point, I have 1.37 times 10 to the minus 16. 1.37 times 10 to the minus 16. This is equal to x to the fourth. Now, this still is an x by itself, so to cancel the fourth, what I want to do is the opposite up to the power of 4 is a fourth root. So if I take the fourth root on this side, I will take the fourth root on this side. Now, some of your calculators are going to have a fourth root button, which you can totally use. But if you don't, and you remember your exponent rules from math in grade 10 and 11, a fourth root is the same as saying the square root of the square root. So at this point, we have our number, our 1.37 times 10 to the minus 16 in our calculator. I can take the square root of that value and then square root it one more time, and I end up with a value of 1.08 times 10 to the minus 4. So 1.08 times 10 to the minus 4, because of course the fourth root canceled to the fourth power. So this value now is x. Now x here has been defined as the concentration of aluminum, and it's been defined as 1/3 the concentration of hydroxide. 3 of those x's would be the concentration of hydroxide. So again, we can't ever stop here just because we've done the math. We have to go, gee, did I answer the question? And the question said, find the concentration of aluminum. Well, we defined the concentration of aluminum as being x, so we're already there. So I'm going to just say this is equal to the concentration of my aluminum ion. Of course, if the question had asked for the concentration of hydroxide, I would have had to say 3x. I would have had to say 3 times x would be the concentration of the hydroxide ion, and then I would have had to multiply this value that we had times 3, and I would have had 3.24 times 10 to the minus 4. And concentrations are always in moles per liter, or we can write the shorthand molar. So it always pays at the very end, once you've got to the point of doing your math, go back and say, gee, did I answer the question? In this case, we had they asked us for hydroxide, we would have had one more step to go.